The potentiometer wire AB having length L and resistance 12R is joined to a cell D. This cell is having an EMF E, okay, or epsilon. So this particular EMF is, let us say, I'll call it E, and there is a cell C over here with EMF E by 2. And the internal resistance of this cell is 3R, the internal resistance of this cell is R. The resistance of the wire AB happens to be equal to 12R. The length AJ, we have to find out the length AJ such that this galvanometer particularly shows zero deflection. This is what has been asked in this question. Now it is very easy to understand that if there is no current passing through the galvanometer, then if we use Kirchhoff's law from point A going in this particular path, and if we reach the point J rather, if we reach the point J, then we can understand that voltage at point A minus E by 2, alright, is going to be equal to voltage at point J. So this is very apparent if we just use Kirchhoff's law along this path. So VA minus E by 2 is equal to VJ. Now because of this we understand that VA minus VJ happens to be equal to E by 2. So that has been mentioned and specified over here. E by 2 is the EMF of this particular cell. So this I can write down as voltage AJ. Now voltage AJ in the primary circuit, so this is the main circuit, if we do analyze, voltage AJ is nothing but the resistance of AJ into the current passing through it. In order to find out the current, we can simply write down current to be equal to the net voltage that is applied in this particular circuit divided by the net resistance. So the net voltage happens to be equal to E, and the net resistance happens to be equal to 12R plus R, so that is 13R. So the current here is going to be equal to E divided by 12R plus R. So this current is nothing but E divided by 13R. So this happens to be the current. Alright. Now let us see how much is the resistance of the length AJ of the wire. This particular length AB happens to be equal to L as specified in the question. The length AJ is to be found out. Okay, let's assume the length AJ to be equal to L, small l. Then in this particular case, we'll know that the length small l compared to the length capital L, will have the resistance given by unitary method. So the resistance will get divided in the ratio of the lengths. So small l upon capital L into 12R. This will be the resistance of AJ. Alright. So if we just take this current and multiply it with the resistance of AJ, then we are supposed to get the voltage drop across AJ. So current into the resistance of AJ, which is RAJ. This will give us the voltage drop across AJ. So this means this is equal to E divided by 13R into L divided by capital L into 12R. And this we have already found out using Kirchhoff's law on the path shown in purple. This we have already found out to be equal to E divided by 2. And hence we'll be able to now find out the length L. This E will vanquish, so will small r. So this I'll get as L upon small l. This will give me L upon small l to have a value of 13 divided by 24. Alright. Therefore, I'll get L is equal to 13 divided by 24 into capital L. So that is option C. Potentiometer circuits are an important part of current electricity and they should be understood thoroughly.